Good morning friends. Today we are going to start with chapter number 3, pair of linear equations in two variables. Right. So first of all, we have discussed that in standard 9 what a linear equation is. A linear equation in two variable is, right? And in the recent chapter we have discussed about a linear polynomial. So today we are going to move further with the pair of linear equation in two variables. So first of all, let us discuss what a linear equation in two variable. What is a linear equation in two variable? Right, a linear equation, as the name suggests, linear. So what do you mean by linear? The degree of the equation is 1, right? And as there are two variables, so you will be having the variables x and y. We are going to introduce a new variable y here, right? We are going to introduce a new variable y here. So there are two variables present to us now, x and y, and as the degree of the equation is 1, so the general form, as we discussed in standard 9, for a pair of linear equation in two variables is ax plus by plus c is equals to 0. So this is the general form of a pair of a linear equation in two variables. Ax plus by plus c is equal to 0, right? But the condition being here is a square plus b square is not equal to 0. Note that the coefficients of x and y, that means coefficients of x and y here are a and b. The sum of the squares of them is not equals to 0. That is the main condition you need to remember. They will not be 0, right? So that is the general form of a linear equation in two variable. Linear equation in two variable, the degree of the equation is 1. And there are two variables present to us, x and y. Right, so that is the general form, ax plus by plus c equals to 0. You note that the powers of the variables here, x and y, present in this equation are both 1 and 1. So that is the linear equation in two variable, right? This is already we discussed in the standard number 9. Now we are going to further move with this topic, that is a pair of linear equation in two variables, right? So a pair, what do you mean by pair? Pair means there will be two same equations that we have written over here. So the pair of linear equation in two variables are generally represented by the general form a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 is equal to 0, right? So this is the general form of a pair of linear equation in two variables, right? Again, the condition as we discussed in the general form of a linear equation is a1 square plus b1 square is not equal to 0 and a2 square plus b2 square is not equal to 0, right? You need to remember this, the conditions for the existence of a pair of linear equation in two variables or a linear equation in two variables, that the squares of the coefficients of x and y, adding them is not equal to 0. Is it clear, everyone? So this is the pair of linear equation in two variables suggests. Again, you also need to remember that the coefficients a1, b1, c1, a2, b2 and c2 are all real numbers, right? They are all real numbers. You need to understand that all these 6 coefficients a1, a2, b1, b2, c1, c2 are all real numbers, right? So mind well that a pair of linear equation in two variables has a general form a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0. These are already or always written in pairs. Let me say, for example, if I write some random equations like 2x plus 3y plus 4 equal to 0, and 4x plus 7y minus 9 equal to 0, right? These are the examples, or this is the example of a pair of linear equation in two variables. See, this is already written in pair here, so that is a pair of linear equation in two variables. In this way you can define any pair of linear equation in two variables, right? Now, as we discussed in the previous chapter, that a linear polynomial always shows the nature of a straight line, right? What does a linear equation or a linear polynomial define? A straight line, right? So in the same way here also we can say that the nature of this pair of linear equation in two variables will always be a straight line, right? What does this linear equation in two variables define? That will define graphically a straight line. Is it clear? So a pair of linear equation or a linear equation in two variables also defines a straight line. We discussed in the previous chapter that if we are writing a polynomial like p of x is equals to 3x plus 4, or we can also write it like y is equals to 3x plus 4. Therefore we can write like 3x minus y plus 4 equals to 0. See, you can get it from here also that this is a pair of linear equation in two variables. In the first step it was a polynomial, but in the last step it is now an equation. Why it is said as an equation and the first one is a polynomial is, here it is written in the form of p of x, or we can also write this p of x is equal to y. So that will define a pair of linear equation, a linear equation in two variables. Now 3x minus y plus 4 is equal to 0. Is it clear? Now, if it is clear till here that what does a pair of linear equation suggest, defines, or what is the nature of a pair of linear equation in two variables, then we are going to plot them on the graph. Let us say we are going to plot them on the graph. We discussed it earlier also, that how to plot a linear equation, a linear polynomial on a graph, right? In the same way here also we are going to discuss about how it is going to be plotted on the graph. So let us discuss the graphical representation. The graphical representation of a linear equation in two variables, right? Now, as it is said that we are having a pair of equations, let me take an example of x minus 2y equal to 0 and 3x plus 4y is equal to 0. Right now I am having these two examples here with me, right? So I need to plot them on the graph. So first of all, what I am going to do if I want to plot them on the graph? Yes, obviously I shall find out the solutions to this equations. That means if I write this as x equals to 2y, and if I write it like x equals to minus 4y by 3, right? So can I write this like these two? Now let me find out the solution to the first one. That is x and that is y. So we shall define some values of y. Let me take y equal to 0. If I take y equal to 0, I shall get x equal to 0. If I take y equals to 1, then I shall get x equals to 2. And if I take y equals to minus 1, then I shall get x equals to minus 2, right? So the solution to the first equation is 0, 0, 2, 1 and minus 2, minus 1. Similarly, I can also find out the solution to the second equation here, right? So if I say these are x and y, let me take y equal to 0, again I shall get x equal to 0, right? If I take y equals to 3, then I shall get x equals to minus 4, and if I take y equals to minus 3, then I shall get x equal to 4, right? So we got the solution to the second equation also, that is 0, 0, minus 4, 3 and 4 comma minus 3. Now let us plot them on the graph. We are going to plot them on the same graph here, right? So that we can see how they are being represented. It is 0, 1, 2, 3, 4. Here it is minus 1, minus 2, minus 3 and minus 4. That is 1, 2, 3, 4. Minus 1, minus 2, minus 3 and minus 4. This is x-axis, this is y-axis, this is negative x-axis, and this is negative y-axis, right? So let us start with the first one, that is 0, 0, this point. Then that is 2, 1. So here you will get a point like this 2, 1, and here you will get a point like this minus 2, minus 1, right? So if I draw a line here through this, I shall get a line like this. That is my line x minus 2y equal to 0, right? So that is the first one, x minus 2y equal to 0. Now I shall write down for 3x plus 4y equals to 0. So again I am having a 0, 0 common. Then I shall have minus 4, 3. So minus 4 and 3, that will be somewhere here in the second quadrant. 4, minus 3, that is 4, and that will be minus 3. So that will be somewhere here in the fourth quadrant. So I shall get a line like this, right? So that is my line 3x plus 4y equal to 0. Is it clear, everyone? So what can you say about these lines being plotted on the graph, right? If I say that the line x minus 2y equals to 0 is here and 3x plus 4y equals to 0 is here, I can say that they both intersect each other at 0, 0. Intersect, what do you mean by intersect? Intersection, that means crossing of two lines at any one point, right? That is known as intersection. So intersecting, this both lines are being intersected here at a common point. What is that common point? 0, 0, right? This is the common point. So we can also say like that, if I put 0, 0 in place of x and y in this both the equations, then I shall get answer 0 for both the equations. That means 0, 0 satisfies both the equations. Yes or no? Then if this point 0, 0 satisfies both the equation, then what can you say about this 0, 0? That point is the solution of both the equations, right? So the main purpose of me solving the graphical graphical representation first is how to find out the solution to a pair of linear equation in two variables graphically, right? How to find out the solution to a pair of linear equation in two variables graphically. So by plotting the lines on the graph, by finding out the solution and plotting these points on the graph to their respective lines, we can also find out the solution of a pair of linear equation in two variables, right? So basically, after seeing this example, we can say that when you are having a pair of linear equation in two variables, the nature of their solution will be of three types. This is one of the examples. The nature of the solution. Solution of the pair of linear equations in two variables, right, and their nature. The solution of the pairs of linear equation in two variables, that if we are having a pair of linear equation in two variables, then the nature of their solution will be of three types, and there will be either one of these three, right, there will be either one of these three. The solution will be either one of these three. Either they will be intersecting lines, either they will be parallel lines, and either they will be coincidental lines, right. They will show either of these three nature. So you can also say that the solution to a pair of linear equation in two variables either will be one of these three. Either they will be intersecting lines, either they will be parallel lines, and either they will be coincidental lines, right. So let me say, for example, if I am having a parallel lines, then how will be they? So intersecting lines, they will form a X pattern here. They will be intersecting at a single point. Parallel lines, that means they will be straight to each other. You can say the best example are the railway tracks, right. Both the railway tracks on which the train moves are parallel to each other. The railway track, a railway track will intersect the another railway track at somewhere, but the rails of the railway track are not going to intersect anywhere each other, right. So they are known as the parallel lines. And coincidental lines refers to the same line on itself, right. That means one of the line or one of the equation representing a line will overlap the another equation representing a line, right. So they are also known as the coincidental lines or coincidental equations. So the solution to a pair of linear equation in two variables will have either of these three nature, right. So again, let us see intersecting lines, parallel lines, and coincidental lines, right. So now from this graph you might come to know that how you can get the solution to a pair of linear equation in two variables graphically, right. Let me give you two examples for which you can define the nature of these pair of linear equation in two variables. So I am writing down two pair of linear equations here, right. From this, try to plot them graphically, and then we shall see how the lines will be, right. So I am writing here, the second example is 2x plus 3y is equals to 9 and 4x plus 6y is equals to 18, and that is x plus 2y minus 4 equal to 0, and that is 2x plus 4y minus 12 is equal to 0, right. So these are the two equations, these are the two pair of equations for a linear equation in two variables that you are going to solve them by yourself graphically. Write it down, 2x plus 3y equal to 9 and 4x plus 6y equals to 18, and the third one is x plus 2y minus 4 equal to 0, and 2x plus 4y minus 12 is equal to 0, right. Okay, now after this graphical representation we are going to come to a conclusion. Graphical representation was to find out the solution of a pair of linear equation in two variables, right. Now after solving these three examples, you might come to a conclusion that what the nature of this pair of linear equations represent, and let us discuss them in a broad concept here, right. Again, we shall take these two general examples only for a pair of equations, that is a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0, right. The comparison we are going to see the comparison of the coefficients of the ratios of the coefficients of the variables. After comparison, we are going to see the nature of the equations, and lastly we are going to see the number of solutions of each of this nature, right? The comparison of the ratios of the coefficients of the variables, that means we are going to take the ratio of the x coefficient of both the equations to the y coefficient of both the equations and to the constant terms of both the equations, such that, like for the first one, if a1 upon a2 is not equal to b1 upon b2, right? If a1 upon a2 is not equal to b1 upon b2, now let us see here what is a1, coefficient of x in the first equation, a2 coefficient of x in the second equation, b1 coefficient of y in the first equation, and b2 is coefficient of y in the second equation. So if I say that a1 upon a2 is not equals to b1 upon b2, then that will show the nature of intersecting lines. That will show the nature of intersecting lines. For example, the first graph that I have drawn here previously was the intersecting lines. So you can clearly confirm from that a1 upon a2 is equals to b1 upon b2 or not. a1 upon a2 there will not be equals to b1 upon b2, right? So you can clearly see from that if this ratio is not equal, then they will show intersecting lines, and the number of solution to this will be only one solution or unique solution, right? Only one solution or unique solution. So again let me repeat it, that if a1 upon a2 is not equals to b1 upon b2, then this condition will show the intersecting lines, and if these lines are intersecting, then the number of solutions to them will be only one solution or a unique solution to the intersecting lines on to the pair of linear equation in two variables, right? So the second one here is, now if a1 upon a2 is equal to b1 upon b2, now they are equal, but that is not equal to the ratio of the constant term, that is not equal to c1 upon c2. a1 upon a2 is equal to b1 upon b2, but this is not equal to c1 upon c2. So in this case we are going to see that this equations given here will represent the parallel lines, right? This will represent the parallel lines. So the example number 2 that I have written here previously, that I gave you in homework to try it by yourself, that is an example of parallel lines. You can check it out from there. If you have written the question, you can check it out, that a1 upon a2 is equal to b1 upon b2 is not equal to c1 upon c2, right? Sorry, I think example number 3 is parallel lines, right? So you can check it out by yourself, that in which category or what the nature will be of these lines, and if they are parallel lines, they will have no solution to the equations, no solution or zero solutions, right? No solution or zero solutions, right? They will not have any solution here to the pair of equations given to you when the equations represents parallel lines, right? How can we define that they will have no solution or zero solution? Because we can see here that they are not going to meet the other equation or meet the nature of the other equation, meet the other line anywhere. and if they do not meet each other anywhere, or if they do not intersect each other anywhere, that means they don't have any solution. So we can say that if the condition exists like a1 upon a2 is equal to b1 upon b2 but is not equal to c1 upon c2, then they will represent parallel lines, and thus parallel lines will have no solution. Lastly, the third one is having a condition like a1 upon a2 is equals to b1 upon b2, but now this is again equals to c1 upon c2, right? a1 upon a2 is equals to b1 upon b2 is equals to c1 upon c2. So in this case, the pair of lines that we have drawn on the graph will be coincidental or coincident lines, and for this you will have infinitely many solutions, right? You will have infinitely many solutions when the condition arises like a1 upon a2 is equals to b1 upon b2 is equals to c1 upon c2. So for example that I have given you, the second example was the coincidental lines. You can check it out by yourselves by plotting them on the graph, right? So if a1 upon a2 is equals to b1 upon b2 is equals to c1 upon c2, then this lines given to you here will represent coincidental lines, and this coincidental lines will have infinitely many solutions. Why infinitely many solutions? Because the lines that we are given here are going to overlap each other, right? They are going to overlap each other here. That means you will see only a single line. But that single line will represent both the equations. So we can say that they are coincidental. That means they are coinciding each other, right? So they are known as coincidental lines, and all the solutions on that line, all the points through which that line is going to pass will be a solution of that equation, right? And we can say that the line that is a coincident line or coincidental lines will have infinite solutions, because that will pass through infinite points, not lines. So they will be coincidental lines and they will have infinitely many solutions, right? So basically you can remember this table and you can calculate that how many solutions the pair of given equations will have, what are the nature of the equations, and what is the comparison of the ratios of the coefficients. These are the important conditions that you need to remember, that if the lines are intersecting, they can ask vice versa also, that what is the condition for intersecting lines. So the condition for the lines being intersecting is a1 upon a2 not equals to b1 upon b2. What is the condition for parallel lines? The condition is a1 upon a2 equal to b1 upon b2 not equal to c1 upon c2, and the condition for being coincidental lines is a1 upon a2 equals to b1 upon b2 is equals to c1 upon c2. Is it clear? So this is basically the table that you are going to remember. One more thing I would like to add here is, what do you mean by consistent and inconsistent pair of equations? Consistent and inconsistent. Consistent equations, that means those equations in which you get at least one solution are known as consistent pair of equations, and those pair of equations in which there is no solution are known as inconsistent pair of equations. So by this define, you can see what is a consistent equations. Consistent equations are those equations which have at least one solution or at least one point that satisfies both the equation is known as a consistent pair of equations, and those equations which do not have any solution, which do not have any point in common, is known as an inconsistent equation. So which of these three are consistent equations? Good. The first one, that is intersecting lines, they are known as the consistent equations, right? So let me write it down here, that intersecting lines will be consistent, then coincidental lines will be consistent. Why these are consistent? Because in intersecting lines we get a unique solution or a one solution present, only one solution, and for coincidental lines we get infinitely many solutions. And as I said, consistent equations are those in which you get at least one equation, at least one, and at most infinite, right? So they are intersecting lines and coincidental lines, and the only inconsistent equation are the parallel lines, so they will give me no solution, and hence they are known as inconsistent pair of equations, right? So you need to remember this, that what are consistent and what are inconsistent. Consistent equations are those in which you get at least one solution, and inconsistent equations are those in which you get no solution or you get zero solution, right? The conditions, the nature of equations, and the number of solutions that are for each and every nature or a pair of linear equation that can possess, right? Take a look. Okay, so now as we discussed the graphical method first before starting with this, now we are going to see how you can solve a pair of linear equation in two variables algebraically. Algebraically, that means by solving them. By three methods that we are going to discuss here in this topic, in this chapter, are the first one, that is the substitution, the second one, that is the elimination, and the third one, that is the cross multiplication method, right? So let us start about the algebraic methods of solving a pair of linear equation in two variables. Algebraic methods. Algebraic methods of solving a pair of linear equation in two variables. The very first one is the substitution. What do you mean by substitution? What do you mean by to substitute? As the name suggests, to substitute, right? Suppose, let me say for an example, if we are playing a soccer game, we are having 11 players on the field, and if any one of the player is injured, then what we are doing, we are going to substitute that player with the player that is sitting on the bench, so that we can balance our team, right? So our player is being substituted by a player over there. So in the same way we are going to substitute, but here we are not having players, we are having variables. So what we are going to do, we are going to have two equations first of all, as it is a pair of linear equation in two variables, right? We are having a pair of equations. Now from any one of the pair, mind well, from any one of the pair, we are going to substitute the value of x. That means we are going to make x as a subject from the second or first equation, replace them in the second equation, then we get the solution to the variables from that method, right? Let me say for an example, I am having an example here, is (7x minus 15y) is equal to 2, and x plus 2y is equal to 3, right? So I am having an example over here, that 7x minus 15y equal to 2 and x plus 2y is equal to 3. Let me define that the given equations are 1 and 2, right? That given equations are 1 and 2. Now see, we need to substitute. First of all, we need to get the value of any of the one variable in the form of the another variable, right? That means if I say that if from the first equation I am going to take out the value of x, then I'll get a value of x in the form of y, then I shall substitute it in the second equation. From that I can get the value of any one of the variable, again back substituting in the first equation, then I shall get the value of the remaining variable also. So it would be easier for me to substitute whenever if you look clearly, that is 7x minus 15y, and here it is x plus 2y. So from the second equation, if I substitute or if I take out the value of x, then what? From equation number 2, I can write it like x equals to 3 minus 2y. This 2y will go on the other side, and that will be 3 minus 2y. Let me mark this as equation number 3. See, this will make me easier to solve the sum, because the denominator here is only 1, nothing for us right now. That means it is 1. Let me say that if I have substituted from equation number 1, some of you might say that, sir, why can't we take out the value of x from equation number 1? Is it wrong or what? So, no, it is nothing wrong over there, but we can say that from equation number 1, if we want to take out the value of x, then that would be 7x is equals to 2 plus 15y, and hence x is equals to 2 plus 15y divided by 7. See, we will get the value of x from the first equation as 2 plus 15y upon 7. Now note that this 7 here in the denominator will make my solution somewhat difficult. Some of you might come with a question, okay, sir, it is not solving. Or some of you might say that, sir, this 7 is here, it is not getting out anywhere, and what to do with this, and saying, right? So it is quite easier for us to get the equation, the value of x from the second equation, that is 3 minus 2y. So what is the conclusion of this? That whenever you see any variable from these two equations having a coefficient 1, right, try to substitute that variable itself. Whenever you see any of the variable, either x or y, from the two equations given to you with coefficient 1, with no coefficient, we can say with no coefficient or having only 1 as a coefficient, try to substitute from that equation and that variable. That will make your solution quite an easier one. Is it clear? So that will make my solution easier one. Now we are going to substitute this equation number 3 in equation number 1. So substituting equation number 3 in equation number 1, we get, mind well, that the value of x that we got here, the x that we have made a subject, is from equation number 2. So we are not going to again replace this value of variable in equation number 2, because that will lead us to nowhere. So if we have took equation number 2, and from that if we have made x as a subject, then that x, that subjected x, is being now replaced in equation number 1, the remaining equation that is left as it is right now, right? So if you have made x or y as a subject from the first equation, then you are going to substitute it in the second equation, and if it is subjected from the second equation, then you are going to replace it in the first equation. Is it clear, everyone? So in this way this substitution works. So substituting equation number 3 in 1, we get, what do we get? Let us see. 7 into 3 minus 2y minus 15y is equal to 2. Right, this is equal to 2. Let us multiply this 7 inside, so that will give me 7 into 3 21 minus 7 into 2 14y minus 15y is equal to 2. Add up this, therefore that will give me 21 minus 29y is equals to 2. That will again lead me to, therefore 29y is equals to 19. And that will give me the value of y, that is 19 by 29. So this is the first variable that we got, that y is equals to 19 by 29. Is it clear, everyone? So we got the value of y here for now. Now what you are going to do? We are going to substitute this value of y, that is substitute y is equals to 19 by 29 in the third equation that we have made as a subject, right? So we are going to take this equation now, x equals to 3 minus 2y, and we are going to replace that value of y here. So what do we get? Let us see. Substituting y equals to 19 upon 29 in equation number 3, we get x equals to 3 minus 2 into 19 by 29, right? So let us multiply, that is 3 minus 38 upon 29. So we need to solve this. Rather than dividing the 38 by 29, we shall multiply cross here, cross multiplying 29 into 3, that is 87 minus 38 upon 29, and 87 minus 38 will lead me to 49. So that is 49 by 29. So that is the value of x that we get here is 49 upon 29, right? So hence what you can say, that the solution to this pair of linear equations given to you are x equals to 49 upon 29 and y equals to 19 upon 29. So in this way you can see how the substitution method works. Is it clear, everyone? Yes or no? Okay, good. Let me take another example so that we can practice it here itself, and then I shall give you some sums for practicing by yourself, right? I am having a second equation, second example. This was the first one that we have solved here is, right? I am having an example like 0.2x plus 0.3y is equal to 1.3. These are all the decimals, and 0.4x plus 0.5y is equals to 2.3. Note that these examples that I am taking here are all from the NCERT textbooks. So you can look over there, and you can also take out some sums by yourself. You can practice it by yourself, and then you can try to solve it by yourself at home, right? So if you are having any doubts, then you can comment me on this lecture. Then let us say that we are having these two equations. So first of all, let us try to convert the decimals into the numbers, right? Let us try to convert them in the form of numbers. So removing all the decimals, or if you see that if you don't know how to remove the decimals, simply write it like 2 by 10 x plus 3 by 10y is equals to 13 by 10, right? 0.2 can be written as 2 by 10, 0.3 can be written as 3 by 10, and 1.3 can be written as 13 by 10. Now you can cancel out the denominators by taking them common. So after solving this, what do we get are the new equations, that is simply transformed from the given equations. They are 2x plus 3y is equals to 13. Let me say that is the first equation, and 4x plus 5y is equals to 23. Let me say that is the second equation. Is it clear? So in this way you can cancel out the decimals and you can get the coefficients as the integers or the whole numbers, right? So we are having the equations now with us. 4x plus 5y equals to 23 and 2x plus 3y equals to 13. Now see, in this case we are not having any of the coefficient as 1. So what we are going to do, we are going to repeat our regular method. Let us say from equation number 1, let me make x as a subject. So we get x is equals to 13 minus 3y upon 2, right? What I shall get? X as 13 minus 3y upon 2. See, this 3y will go on the other side, and the coefficient of x, that is 2, that will go in division of 13 minus 3y. Substitute equation 3 in, where shall we substitute now? Good, in equation number 2, because we have took out the value of x from the first equation. So now again we are not going to substitute that x equals to this thing in first equation, because that will lead us to nowhere. So we shall substitute now this in the second equation. So substitute 3 into, we get, what shall we get? Let us look over here. That is 4 into 13 minus 3y by 2 equals to, plus 5y equals to 23. Right, you can cancel this out, 2 and 4 by 2. So this 2 will be multiplied, that is 13 into 2, 26 minus 6y plus 5y is equals to 23. Minus 6y plus 5y, that is minus y. Therefore 26 minus y is equals to 23, and hence I shall get y is equals to 3. If you take y on the other side and 23 on this side, that will become minus y as plus y, and this 23 will become minus 23. Hence 26 minus 23 is 3. So we get y equals to 3. Right, now substituting again, what do we do? Substitute y equal to 3 in equation number 3. We get, what do we get? Let us see what do we get here is x equals to 13 minus 3 into 3 upon 2. So what is 3 into 3? Good, 9. 13 minus 9, that will give me 4. So that is 13 minus 9 by 2, that is 4 upon 2, and hence we get x equal to 2. Right, so what is the conclusion from this? That the solution to this given pair of equations in two variables is x equals to 2 and y equals to 3. Is it clear everyone now? Right, so this is basically the substitution method, that how we can get the solutions of, or how we can get the solution of a pair of linear equation in two variables by using the substitution method. Take a look over it. Okay, so now I've written two more questions for you to do it by yourself. The first one is a pair x minus 7y plus 42 equal to 0 and x minus 3y minus 6 equal to 0. The second one is 3x by 2 minus 5y by 3 equals to minus 2 and x by 3 plus y by 2 equals to 13 by 6. Try to do it by yourself in the same way that we have discussed the rest of the two solutions, and then try to find it out. Right. There is one more question written here on the board, that sometimes the paper setter might set a question that they will not give you direct equations. They will give you a data type question. So first of all, the thing that you need to do is you need to form an equation, and then you are going to solve it, right? So it is said that the difference of two numbers is 26. The difference of two numbers is 26, and one of the number is 3 times the other one. One of the numbers is 3 times the another one. Find them. So here we are talking about two numbers such that the difference of both the numbers is 26. There may be infinite numbers or infinite pair of such numbers whose difference is 26, right? But there will be only one pair such that one of the number is 3 times the another one. There might be some more, but we are going to do it like this here, right? So let the solution starts here. By assuming that let the numbers that we need to find out be x and y, right? Here I have written only x and y, so you can say that what will, now you might say what is the larger number, what is the smaller number, because the difference is 26. That means one of the number will be larger and the another one will be a smaller one, right? So let us say that let the numbers that we have assumed is x and y, where x is greater than y. This is important that you need to remember, where x is greater than y. X is greater than y, that means the number x that we have assumed here is larger than the number y that we have assumed, right? So this is greater and this one is smaller in comparison to the greater one, right? Let the numbers be x and y where x is greater than y. Therefore, or so, according to the given information, we can see that the difference of the two numbers is 26. Therefore, x minus y is equals to 26. That leads me to the first equation, that is x minus y equals to 26, and one number is 3 times the another one. One number is 3 times the another one. Which will be 3 times the other one? Smaller or the greater one? Exactly, the greater one will be 3 times the smaller one. You can say it like that, one number is 3 times the other. That means the greater number will be 3 times the smaller one. You cannot say that the smaller is 3 times the greater one. Then it will become greater than the greater one. Is it clear? So mind well that one number is 3 times the other one. That means the greater number is equal to 3 times the smaller number. That leads me to the second equation, that is x equals to 3y. So we got the equations here now. And once we get the equations, we can try to solve them. So let us use the substitution method here itself. We are having the second equation directly as a substitution, directly as a subject of x. So substituting directly, substitute equation number 2 in equation number 1, we get 3y minus y is equals to 26. Therefore 2y is equals to 26 and therefore y is equals to 13. So we got the smaller number as 13. Now once we get the smaller number, you can judge from this that what must be the larger number. Exactly, that must be 39, so as to get the difference of 13. Now substitute y equals to 13 in 2. Here you can replace this in any of the equations. It is not compulsory to replace it in 2. It would be easier if we replace this in 2, but you can replace this in any of the methods, any of the equations, that is in first or in second. So in 2, substituting this in 2, we get x is equals to 3 into 13. Therefore x is equals to 39. Right, so x is equals to 39 is the greater number and y equals to 13 is the smaller number. Therefore the numbers are 39 and 13. So these are our required numbers, that are 39 and 13, which satisfies the given conditions. The difference is 26 and one of the number is 3 times the another one. Is it clear, everyone? So you might take a look over here and you can see that how it is being solved, right? What you are going to do is, whatever the thing that is asked to us to find will be assumed here. The numbers are in a difference of 26. So first of all, we need that number, so we need that reference things, that what the numbers will be, how they will be used. So we shall let the numbers, assuming that the numbers are x and y. If we assume them as x and y, then according to the given conditions we can form the equations, and once we get the equations we can solve them by our algebraic methods. Right now we are solving about substitution, so we can solve it by the substitution method. Is it clear, everyone? So take a look over it and then we shall move on to the next question. Okay, moving further with one more sum here. I'm having one more sum here with me. Let us say a coach of a team buys 7 bats and 6 balls for rupees 3800. Later, she buys 3 bats and 5 balls for rupees 1750. Find the cost of each bat and each ball. Right, so the condition here right now that exists before us is a coach of a team buys 7 bats and 6 balls for rupees 3800. So that is the first condition. Later again, she buys 3 bats and 5 balls for rupees 1750. So that is the second condition. We need to find out the cost of each bat and each ball. The cost of each bat and each ball. So as I said that the thing that is asked to us will be assumed. Right? Whatever the thing that we need to find out in the given question, that will be assumed with the variables, so that we can easily solve the conditions we can easily convert the conditions in the form of an equation, and then we can try to solve. So the solution starts. Let the cost of one bat be rupees X and that the cost one ball be rupees Y. Let the cost of one bat be rupees X and let the cost of one ball be rupees Y. Therefore, according to the given condition, what is that according to the given condition? So according to the given condition, we can say that in the first condition it is 7 bats and 6 balls. So that will give me 7x plus 6y for how much rupees? That is 3800 rupees. So 7x plus 6y is equals to 3800. That leads me to the first equation. And according to the second condition, we are having 3 bats and 5 balls. So 3x plus 5y, that will give me 1750, and that leads me to the second condition. Is it clear? So that is 7x plus 6y equals to 3800 and 3x plus 5y equals to 1750. Right, now we are having the equations. Let us try to solve them. I shall use the second equation first because it has the value of the coefficients lesser than the first one, smaller than the first one. Right, here it is 3x and 5y, here it is 7x and 6y. So from the second equation, I shall take x as a subject. So x is equals to 1750 minus 5y upon 3. Right, I got the value of x here, that is 1750 minus 5y upon 3. That is number 3. So what we are going to do next is substitute. Substitute the third equation in the first and not in the second. So we get, what do we get? Let us see. 7 into 1750 upon 3 plus 6y is equals to 3800. Right, now it is not going to cut anywhere, so let us say that we need to take the LCM over here itself. So that is 175 into 7. 12250. Yes, it is 12250 minus 35y upon 3 plus 6y is equals to 3800. Therefore 12250 minus 35y plus 18y equals to 38 into 3, 11400, right? Yes, therefore this will be subtracted. 12250 minus 17y is equals to 11400. Therefore 17y is equals to, let us see the subtraction here. That is, I think, 8500, right? 17y, that is equals to 12250 minus 11400, and that is 8500. Sorry, not 8500, it is 850. My mistake, that is 850. So that is 17y is equals to 850. And hence we can get y is equals to 17 into 5 is 85, I think. So that is y equals to 50. Right. So we got y. What is y here? Cost of one ball. So cost of one ball is 50 rupees. Now what we are going to do next is substitute. Substitute y is equals to 50 in the third equation. What shall we get? Let us look over here. We get x equals to 1750 minus 5 into 50 upon 3. So that is 1750 minus 250 upon 3. That is 1500 by 3. And that is equals to 500. Right? So this is what we get here, that x equals to 500 and y equals to 50. Therefore, cost of one bat is rupees 500 and cost of one ball is rupees 50. So in this way you can get the solution of the given problem, that is the data type question, by solving them by a substitution method. Is it clear? Okay, take a look over it.